All right, so here we go. Number 9, 11, and 13. We want to try to do the best we can. So, just derivatives. You remember them, right? If I want to take a derivative of this, right? Chica, help me. The derivative, remember, it's the exponent times the coefficient, right? Chica, help me, help you.
Wait, I write these down yet, Dan.
So, what is 2 times 5?
10.
There you go. Alright? And then what is 1 taken away from 2? A 1. Good job. So, the derivative is just 10x. Right?
That's it.
That's it.
Cake.
Right?
Cake, no walk.
Take, walk. Alright, so then what's the derivative to this one? What is 1 times a half?
1.5.
No. 1 times a half.
1. I don't
No.
know.
Isn't it half?
Dan,
Half. There you go. It's a half.
Oh, it does. Never mind.
It's 1 times a half. It's itself. It's a half.
Our IQ's
Right? Okay, what if I take 1 away from 1? There's nothing. Good. Then there's no x here, right? Now we go to the next one. What's negative 4 times negative 4?
16.
Positive, right?
Yeah.
So plus 16, and then x to what power? If I take 1 away from negative 4, what power is that?
Oh, isn't it negative 5? Oh no.
Yeah. Negative 5.
Come on.
Now, how would I rewrite that so it looks good? So, the way I would rewrite this is y prime is equal to, the x's come first, and remember, because this is negative, we're going to take it down below, right? So I'm going to go 16 over x to the 5th, alright? Plus 1/2. Okay? What?
Damn.
Where did
Oh!
Dan, where's
Oh, all day!
You almost broke your
You
window.
missed that.
That's alright.
Where's negative 1 coming from?
Dan, you missed.
I did it, it's in there.
No, it's not. It's right by the garbage.
No, that's a different one.
No, it's not.
Bet.
Bet.
Go look. Bet. It's on. It's on. Donkey Kong.
Dan, where's the negative 1 coming from?
Where? Here?
Yeah.
Because you always subtract 1 from when you're done doing the power, right?
Ah.
Was there 1 in there? Was there 1 in there? Did I dip it? Did I dip it? Oh, come on. Give me a break.
You did.
Once in a while I do make it. Alright, so alright, so that's the answer right there, yeah?
Look at her over here trying to touch you up, huh? Touch
Okay.
up on you.
So number 13. Should I pause it and then start it again? Or just keep it going?
I don't know. I feel like mine's just keep it going.
How many minutes is it? 3? Oh yeah, we can keep it going. Let's go. Let's go! Alright. Let's go! Alright. What are we doing? Remember, 4 times this, right? So, what's happening here is I'm taking negative 5/4 and I'm multiplying it by 4 over 1, right? And these 4's cancel. And I'm left with negative 5. Then I subtract 1 from that 4, and what do I get?
Wait, I
3.
forgot where the negative 1 comes from. I'm trying to write notes, but I forgot.
It's always minus 1,
From why?
because that's part of the power rule.
Okay.
You multiply by the power, subtract 1 from the exponent.
Why is it so hard?
Guys, stay focused.
My fault.
Alright, next, another color. I'm going to change colors on each of these. It's just easier that way. So now I have this power, right, multiplied by that coefficient. So what I'm really doing is I'm taking negative 1/5 and I'm multiplying it by 5/2. Okay? Now, A negative and a positive leaves it a negative, right? But these 5's cancel. So what am I left with? 1/2, right?
Boom.
And then what is my x? So I'm going to subtract 1 from the 5/2. Now here, I'm going to go another level. I'm going to say 5/2 minus 2/2, because that's the same as 1, right? Because the bases have to be the same in order to subtract. So what is 5 minus 2? So that's where we're going to get x to the 3/2. Okay? Then I'm going to use another color. Alright? Can I use orange? Or you can't use red. We already discussed that. Or should I use purple?
We're not even looking at it right now. I'm doing this.
Orange.
Orange? Alright, here we go. Now what is 5/3 times 1? 5/3. So that's plus 5/3. And then if I take 1 away from 5/3, remember that's the same as before. 5/3 minus 3/3, right? Okay, because the bases have to be the same. We're subtracting 1. And so what do we get? We get 2/3, right? So that's x to the 2/3. And that, my friends, is what's going on. Right? Now, if you wanted to write this in a radical form, then this would be written as minus 5x cubed, right? Minus, now you never have a radical in the bottom, right? So this would be over 2, and this would be x cubed, right? Square rooted. Does that make sense? The square root comes from that square.
Yeah.
Okay? Now, then it would be plus 5/3 x. Now, in this case, let's move the x over a little bit. X squared, and this is going to be to the 3rd. So it's actually a cube root. See the difference? This is a square root. This is a cubed root, because the root of a plant, right, is in the bottom. And so your root is always in the bottom of the fraction. That one can be a little difficult to write, but once you get used to it, it's super easy. Okay? So you can write it in either form or both forms. I'd like to see you write it in exponential form and in fractional exponential form. So let me rephrase that. In exponential form, right? So this is exponential form, and this is radical form. Okay?
Okay.
So one shows the radicals, one shows the fractional exponents. We good? Questions? Fun stuff?